everyone, welcome to our lesson on inverses of cubic functions. To talk about cubic functions, we need to first review what an inverse is. So we're going to talk about that first. An inverse of a function on the graph is going to be reflected over that special line y equals x, that diagonal line that's going through the origin. So anytime we talk about inverses, that's going to occur. And then functions, the word function in general, means that each x is paired with only one y. So when we go take a look at this, let's recall the line y equals x, which is here, and take a look at what a reflection over that line looks like. If we had, for instance, maybe some picture on our graph that looks like this. This is not the cubic or cube root function, but a reflection over this line is easier to see with something over here in the third quadrant. So if we wanted to reflect it over this line here, we would flip it around there, and its mirror image on the other side would look something like that. So that's what a reflection around the line y equals x looks like. It's harder to see it when you have a line, a linear function, sometimes, or a parabola, a quadratic. But that is what it is supposed to be. Alright, so let's also talk about functions as a whole before we take a look at this particular function. Remember we said that to be a function, that means that every x is paired with one y. So when we look at the cubic function, the normal curvy cubic function, something like this, which is a function, you may remember talking about a test you can perform to find out if something you're looking at is a function, and that was called the vertical line test. So if you can draw vertical lines anywhere through your picture, you have to be able to do it anywhere through the picture, and only hit one location on each of those lines that you're drawing on your function. See our locations here? Then that means that what you're looking at is a function. That's because your x value location that you're at only has one y location. Okay? If we were looking at, let's say, something like this. Okay? And we performed the same vertical line test, we would start drawing our vertical lines, and we would notice that over here on this left-hand side, anywhere I draw one, really for a while through this function, I'm going to hit two locations. So that means what I'm looking at here is not a function. So that's just a basic review of if we know if we have a function or not, the vertical line test. So the particular function we're looking at is the inverse of the cubic function. Okay, so I drew a parent graph cubic function on the previous slide. So we're going to find out what the inverse looks like. So this here is just an example of a cubic function. So we're going to find the inverse, and then we're going to go graph it so you can see what it looks like. So we've got f of x equals 1/2 x cubed. Now if you recall the process for finding an inverse, that involves 3 steps. The first step is to replace f of x with y, and then we're going to switch x and y locations, and then we're going to solve for y. That will give us the inverse of what we see here. So step 1 is to replace f of x with y. So I really have y equals 1/2 x cubed. Okay, now I want to switch x and y, so we're going to switch these two here. So we will have instead x equals 1/2 y cubed. And now we want to solve for y, which means to get y isolated by itself. So we're going to do the opposite operations of what we see to make that happen. So I have a 1/2 multiplied by y cubed, and to undo that 1/2, I'm going to use a 2 over 1. So I'm going to multiply both sides by 2 over 1. That's going to get rid of my 1/2. It's going to cancel everything out there. Alright, so on the left-hand side, I'll have 2x. If I simplify, equals y cubed. I need y to be totally isolated, so I don't want that cubed power there, so I want to undo that as well. So what undoes a cube power is a cube root. So I'm going to need to take the cube root of both sides to do that. Left-hand side and right-hand side. So I've got cube root of 2x equals y. So we have now found the inverse of this original function up here. Alright, so cube root function. So what would one of these look like on the graph? Cube root of 2x. Let's go see. Alright, if you have a graphing calculator, you can type this in to the y equals screen and you can get your table of values and get many points you can plot to connect here. If you don't, you can make an XY table of values, something like this. And you can begin to plug any X number in that you want and calculate out to find the matching Y. If you do that, you're going to get a couple of points. I've found a couple of points for us here. This graph's going to go through the point 4, 2, and also -4, -2. And you can continue to test and get other points. You do want to test many values to get the most accurate picture that you can. Okay, so remember the cubic function picture looks sort of like a curvy shape. Alright, so we're going to take a look and see what this one looks like. Okay, if you continue to test points, you're going to get the graph to go something like this, in this direction. And you can see that it sort of looks like its original cube function relative, but it has been reflected, remember, over that line y equals x, because this is now the inverse of that previous picture that we looked at. So this is an example of a cube root function. You can see also, you can make sure that it still is a function by remembering the vertical line test. If you were to draw those vertical lines that we talked about anywhere through this picture, you can see you're only going to come in contact with the function one time with each vertical line. So that means that the inverse of a cubic function is still a function. So any kind of cubic function you look at, ours was had a little bit of a stretch to it, but you may see something that's a little wider. But you can see that no matter what type of cubic function you have, even if it were reflected, if it were reflected across the x-axis and did sort of the opposite, you can see that you can draw those vertical lines and you will not touch more than one location with each vertical line. So that means that the inverse of this function is also a function. So that concludes our lesson on inverses of cubic functions.